In the previous class, we have discussed R programming is very much useful for statistical analysis. Now, what is statistical analysis? I'm going to explain. But before that, I want to tell you one thing, that is, whenever we have our data set, then we have to perform some kind of analysis. And why this analysis are important? Because this analysis are important in order to understand the data properly. And once you have understood your data properly, then only you can apply any machine learning algorithms to get some output. So, what is our discussion? So, each day we are talking about statistical analysis. So, whenever we are talking about statistical analysis, now you can explain the simple concept. That is, statistical analysis is all about understanding the internal behavior of the data. And once it is understood, then only we can use some machine learning algorithm in order to predict or classify. Now you can ask me one question: why we need analysis in order to understand data? Now I'm giving you one example. See, this is a data set. It is known as wine quality data set, where these are the features. Feature means these are the input parameters, or you can say that these are the inputs. That is fixed acidity, volatile acidity, citric acid, pH, density, total sulfur dioxide, free sulfur dioxide. So these are the features on the basis of which we can find out the quality of the wine. Here my point is, see, whenever we are dealing with some data set, whatever may be the format, this data set is in CSV format. See, we have multiple number of features. Means we have multiple number of inputs. And on the basis of these inputs, we can find out what is the quality of the wine. So now what is the problem? So this is the point why we need some kind of analysis on our data set, because which features are most important to find out the quality of the wine, we have to find out that. Because whenever in your data set you have multiple features, it does not imply that all features are important. Some features are important and some features are not important. So we have to find out this thing. And also we have to find out some statistical measurements like mean, max, standard deviation, so that we could explain or understand our data set in more details, right? So for that purpose, sometimes we will use some kinds of plots, because visualizing data in a CSV file is difficult, very much difficult, because we will not be able to understand this multidimensional data. So it is better if I represent this data in a graphical format. Then it is very much easier for a human mind to visualize that data. So for that purpose in R, we use some kinds of plottings that will depict the behavior or the underlying statistics of the data. So see, today we are going to learn linear regression. So first we have to focus on this, that what is this linear regression and why we are concerned about this linear regression. And then we will perform some coding, right? So now if you ask me this question, what is linear regression? So I will tell you, it is a machine learning algorithm, and it is a special kind of machine learning algorithm which is known as supervised machine learning algorithm. Supervised machine learning algorithm means where we have to predict the output, and this output is basically continuous in nature. See, I'm giving you one overview. What do you mean by supervised learning? See, supervised learning is something in which you have a teacher or supervisor. Means by using all this input, what we are going to find? We are going to find the quality of the wine. Since this target value is given to us, it means we have some support means if fixed acidity, volatile acidity, citric acid, so these are the inputs, then what should be the quality of the wine? It is type 6. Then if these are the types of inputs, then what is the quality of wine? It is type 5. So basically, for which kind of input, what kind of quality of wine we can get, this is given. So whenever the target is given with respect to the corresponding features, then it is known as supervised learning. So this guideline is given to us. So here my point is, what is linear regression? Here linear regression is a supervised machine learning algorithm. Here what we are doing, we are going to predict some output. So output prediction we are going to perform, right? And you have to remember one point, this output must be continuous. Continuous means say some output feature like cells. So value of the cells is a continuous value, or we are going to predict price of something. So whenever we are talking about price or cells, so these values are continuous. So here using linear regression, whatever output we are going to predict, they are continuous in nature. So this thing you have to keep in mind. Means by using linear regression, say if we have some categorical data of cats and dogs, you cannot classify them. Means you cannot categorize which one is cat, which one is dog. This kind of classification is not possible, right? So my point is, whenever you have your data set like feature 1, feature 2, feature 3, and whenever you have your output or the target that you are going to predict, in this case we have wine quality. See here, if I ask you this question, that is, this is the data set, can you perform linear regression on this data set? Then your answer will be yes. Why? Because we are going to predict what? Quality of the wine, and see, it is a value. But now my question is it a continuous value or is it a categorical value? Means can I perform linear regression on the basis of wine quality? See, we have 6, 5, 7, this kind of numbers. It is not a continuous value. So instead of quality of wine, if we have wine price, so in this data set, in this column, if we have wine price, then what will happen? So price of something is a continuous value. Say on the basis of this feature, say we are going to predict the price of wine. So at that point of time, we can use linear regression. So now we are moving to the second part. Now we have two types of linear regression. The first type is known as simple regression, and the second type is known as multivariable regression. So now let's talk about simple regression. See, simple linear regression uses traditional slope intercept concept. So what is this traditional slope intercept concept? See, we know this equation, y equal to mx plus b. So this is the equation, right? So here m and b, they are variables, right? So here, say simple regression is using this equation. It means basically my algorithm will try to learn this variable m and b. So here my point is, simple linear regression uses slope intercept concept where m and b are the variables of our algorithm that it will try to learn. And why it is trying to learn this variable? So that it could produce some accurate prediction on x. So basically producing the accurate value of x by learning other two variable m and b, and since it is a linear equation, this is the ultimate objective of simple linear regression. Now, if you ask me this question, okay, this concept is understood, but what is this multivariable regression means? Say, multivariation regression means it is a complex kind of regression where multivariable linear equations are present. For an example, say we have a function like x, y, and z, and say we have the equation like this: w1x, w2y, and say w3z. Right? So here x, y, and z, this represents some attributes, means these are the variables. So these are representing some attributes or features, for an example. And so this is the equation. So at that point of time, we have three variables. So basically my point is we may have more than features, means we have more than one variables. So whenever we are dealing with this kind of equation, where the concept of W represents the coefficients, or you can say that it is a weights. And here our model is basically trying to learn these weights W1, W2 and W3. So in multivariable regression, learning the coefficients are the ultimate objective of the algorithm. And what it wants to predict? It wants to predict x, y and z, the variables present in the equation. Means I'm giving you one simple example. Say the equation is like this: sales. So we are going to find out the sales. So we are going to predict the sales. So we just write W1, sales of a radio, then sales of TV, and say sales of some news articles or news. So in this case, by using multivariable regression, we are going to predict the sales. Basically, we are going to find out these values while by learning W1, W2 and W3. So here learning coefficients and weights are the ultimate aim of the algorithm. So whenever we are using linear regression algorithm for simple regression, then learning this M and B in order to find X. It is the objective, and here we are finding X, Y, Z, three variables or many number of variables on the basis of learning weights which are associated with it. Right? So this is the concept of simple regression and multivariable regression. And we know that how we can predict cells using the linear regression or multivariate regression concept. See, we can predict cells because it is a continuous value. Whatever we are predicting, it is continuous in nature, we can apply linear regression. So this is the basic concept of two types of linear regression. So I'm just giving you one simple example by which we can understand linear regression in more details. That is, say I'm talking about this linear regression, and now our question is how we could implement this concept of linear regression using R. So this thing we have to keep in mind. Now today we will only talk about linear regression. Right. So up to this we have discussed that linear regression is used to predict the value of an outcome variable, say y, on the basis of one or more input predictor variable, say x. So these are also known as features. So on the basis of one or more features, it is going to predict some outcome y. So up to this is our discussion. So now here how we can use this concept in R in order to perform coding. Before that, I want to tell you some terms. So whenever I am talking about linear regression, see, we can write this kind of equation. So this equation is used in linear regression. Here, this y is also known as response variable, and x is a predictor variable. And here, what is this a and b? A and b are known as constants. So this thing you have to keep in mind. And these constants are also known as coefficients. So these terms you have to keep in mind. So whenever I was discussing linear regression, I have clearly stated that learning constants or learning coefficients is the ultimate objective of the algorithm in order to predict the response. Means in order to find out the accurate value of x. So this is the concept. Now we have to understand what are the steps for establishing the regression. So these steps we have to keep in mind, and we are going to follow all these steps while doing the coding. Now what is the first step? So in the first step, we carry out the experiment of gathering the sample of observed value of say height, weight. So whatever feature we are going to use, the first step is we have to gather the sample, or you can say that we can gather the data set. So this is always the first step. Now what is the second step? So the second step is create relationship model. And this relationship model is created in R using a function which is known as LM function. So in the second step, we have to use this LM function to create the relationship model. Now come to the third step. So next step is find coefficients with the help of the model and create the mathematical equation using the coefficient. So finding coefficient is one step in this third stage, and also we have to create at the same time the mathematical equation using this coefficients. So whatever coefficients we are finding, we have to create mathematical equation using this coefficients. So this is the third step. And what is the fourth step? So in the fourth step, we will basically get a summary of the relationship model. So whatever relationship model we are creating, we will get the summary. Now why this summary is important? To understand the average error in the prediction, which is also known as residuals. So this thing you have to keep in mind. So at the fourth step, finding summary of the relationship model, means whatever model we are using, that is a linear regression model or multivariate regression model, anything, whatever model we are using, we have to find out the summary of the model. This summary of the model will tell us what is the average error this model is getting, because you know that whenever we are using any machine learning model, on the basis of some input, whenever we are predicting some outcome, whatever outcome we are getting, it will not be 100% accurate. Always it will give some amount of error. So what is our target? So whenever you are using any machine learning algorithm, the only target is you have to find out such a model that will give you the minimal error. So optimizing the error is only concern whenever we are using machine learning model. So any machine learning model is prone to error. So at the fourth step, we are just finding out what is the average error which is encountered by this relationship model, and average error encountered by any relationship models are also known as residuals. So at the fourth step, we are going to use summary function in order to get the residuals. And what is the fifth step? At last, at the fifth step, what we will do? Now finally, we will predict. So predict functions to predict the weights of the predicted value. So we have already discussed, so finding weights or finding coefficients are the ultimate option. So finally, we will apply the predict function in order to get the outcome. See, in the fourth step, we will get the summary of the relationship model to understand the average error in prediction. So here my point is, try to understand this concept. I'm using one machine learning model. So whenever you are using any machine learning model, basically first you have to train the model, right? How you can train the model? You can train the model by giving appropriate input and by stating what is the corresponding output whenever this kind of inputs are given. So you can say that training is just like teaching students. So in machine learning model, what is your expectation? Your expectation is your machine learning model will predict something. It can only perform prediction if you are training your machine learning model properly. Training means give machine learning model appropriate input with an appropriate output, just like this. So whenever I am just training my machine learning model, I will give all the features as well as the quality of the wine. So for which kind of feature, what is the quality we can expect? So we will give all the features like this. So now after giving this input, the machine will tell us that how much it has trained, means how much it has understood. So that understanding will not be 100% because whatever I am teaching in the class, it is not possible that every student is understanding 100% of this content. So there will be some lag behind, there will be some points which are not understood by the students. So that is known as residuals. So here, whatever relationship model we are using, by using summary function, we can find out the average error in understanding or average error in training procedure, which is known as residual. And if this residual is high, means there is lots of error, then we will again retrain our model. And if this residual is very low, means our model is ready to predict. So now what do you mean by prediction? Prediction means after this training part is over, now what we will do, we will pick up some random values like this. And we will only pick up the features and we will feed it to the machine. And then machine will give us some outcome. Then we will check whatever outcome our machine is giving, whether it is matching with our actual solution or not. So prediction means we are testing the machine. And while testing, we will only give the features, not the outcome. So after giving the feature, the machine will give us some output which is known as predicted output, and then we will compare it with the actual output. Actual output means whatever output is given in your data set. So here my point is how this linear machine learning supervised algorithm will work. After gathering the data set, we have to use one function, that is lm, and then we have to find out the coefficients, and also we have to create the mathematical model, because for linear regression whatever equation we are using, it is not same for other regression. And then we have to perform the fourth step. So this fourth step is dedicated for training, means how much our model has understood whatever features and outcome we are giving. And on the basis of that, we will evaluate the average error, means the residuals. And once this residual value is very less, now we will invoke predict function, means we will just give the features and we will wait for the machine so that it could give us some output, right? So this is the algorithm for linear regression. So this is the concept of machine learning. So that's why the fourth step and the fifth step are very much important. So here, whenever we are talking about multivariable regression or multiple regression, so at this point of time, what will happen? See, we have 3 or 4 variables, right? Each time we are going to learn weights. We are adjusting the weights W1, W2, W3. So if we can learn weights properly, then my residuals will be less. So here at this point of time, we have to find out one optimal balance. That's why I am not stating the minimal error. I am just telling that optimized error means we have to set the value of W1, W2, W3 in such a way so that we can get an optimal error. Say value of W1 is 1, value of W2 is 1.2 and value of W3 is 0.33. So this is the ultimate value that I am getting, which is giving me the optimal error. Optimal error means if I go beyond that, my error will not change. So actually finding the optimal values of the weights is the only target. So this is the concept, right? And this thing means whatever pattern we have discussed so far, it will be same for all machine learning algorithms. So what is the difference then? See, the difference will be here. So whatever relationship model we are going to develop, this relationship model will change. Means the algorithm will change. So in machine learning, we have many supervised algorithm. So it will change accordingly. But training and testing concept and finding the residuals, everything is same. So these are the 5 steps that we have to keep in mind for linear regression. Now concentrate on the implementation part. So gathering dataset, we know that how to gather dataset because we have already discussed how to download CSV files from different repositories. Now the part is we have to create the relationship model. So here we are dealing with linear regression. So for that purpose, it is fixed that in R you have to use LM function. So now we have to understand how this LM function will look like. See, the LM function will look like this. LM and then formula and then the data. These are the arguments. Means LM function will accept 2 arguments, formula and data. Now what is the formula? See, it is the symbol that presents the relationship between x and y. X and Y means predictors, means features and whatever we are going to predict. So relationship between these two, feature and the outcome, this relationship is depicted by this formula. And data means, if I tell you technically, they are the vectors which we are going to apply. So vector means it may be a data frame, it may be a vectors, anything. So in which format we are accepting the data, it will be in that format only. So this is the syntax of LM. Now see, I have created one code over here. Now try to understand this code. See, we don't have our data set, right? So what I have done, I have created 2 vectors. This is one vector and this is another vector. Now you can ask me this question that how could I understand that it is a vector? So I've explained that vector means all the elements will be pass through this C function. C function means combine function. So these combined functions are used to combine the elements of the vector x and y. Now you can ask me this question that why we have x and y. See here x means the features, the input and y means the output that we are going to predict. Y means the cells. We are going to predict cells on the basis of some input. See, if I'm talking about these values, now you can ask me this question whether these values are taken row wise or column wise. See, whenever I am giving the value of x like this, it means in the data set, x means it is a feature. So I'm talking about one feature. Say fixed acidity means x. And whatever value I am taking using combined function, all those values are considered as column wise. So this value represents one input column. And similarly, what is y? Y is the output that we are expecting and it's also depicting the column like this. So here we are going to find out the quality and this is the value that we are writing over here. But unfortunately, it is not possible to find out quality of the wine using linear regression because it is not a continuous value. So if we have the column like price of a wine, then that price we can find out using linear regression. So here, since I don't have any value right now, so I can use the wine dataset also. But for simplicity, I'm just taking one input feature X and one output feature that is Y. Right. Now here say I'm using LM function. So how I'm using this LM function? See, this LM function will look like Y, then tilde symbol, then X. So it means we have to always write in the left hand side whatever we are going to predict. If we are going to predict the column cells, in the left hand side we will write cells and then tilde sign, and then in the right hand side we will write the input features. So this is how we can write the LM function, right? And then what will be the third step? Repeatedly I have already explained that whenever we are dealing with linear regression, our ultimate aim is to find out the coefficients. Means these are the constants that we are going to find out. So here, see, we are doing the same thing. Here we are finding what? Here we are finding the coefficients, and also we are printing the coefficients. So this is the next step. So this is the algorithm, you can say, we are just creating for the purpose of coding. So now after that we have the final step, which is known as prediction. Now for prediction, I have used some specific plots by which we can get the output. So let's see what will happen. So these are the two vectors which are created, and then we are using LM function. See, using LM function means the function is already written and the model is created right now. And then we are printing the coefficients. So here we have the coefficient values. See, intercept, these two coefficients I am using. So these values they are printing. So if you are using this equation, y equal to mx plus b, so it will print the value of m and b, right? The intercept value and the slope value. So this is your coefficient. You can change according to your coding. And then see, the summary function is very much important. And see, whenever I'm just clicking on summary function and see what values they are giving. See, there are lots more things. You are expecting that summary function means it will give us the average error. And average error means residual. So we are expecting that one value it will give us. But see, what are the different kinds of value they are giving? They are giving residual standard error, they are giving multiple R square error, they are giving adjusted R square error, they are giving F statistics. So finding residuals and understanding the residuals are not so easy. So for that purpose, we have to understand each and every terms properly. So this is the point why we need statistical analysis in R. So whatever coding we have performed so far, we are expecting that by using summary function, we will understand that what is the average error we are getting. Then only we can predict. But understanding summary function is so difficult because it is associated with some statistical analysis value. So now in the next class onwards, we are going to learn what is the meaning of each and every term that we have mentioned over here. But I'm just showing it to you. And what is the meaning of this? I will tell you. So finally, I have created one code in which you can expect the outcome. So here what happens, see, this is the linear regression plot. See, I have plotted height and weight, and see, this line is known as linear regression. So whatever data points we are having, since it is following the mathematical model y equal to mx plus c, so here it is creating a straight line and it is trying to fit the model. And here the model is not good because this model is not fitted properly. Why not? I will explain it. But always for a linear regression, we can expect this kind of output. But in order to understand the summary function, we have to understand the formula of F statistics p values. So what I have done, I have created one file for you all where I have mentioned each and every formula for each and every term which is associated with summary function. That is, I have used two vectors over here. Then here I have created one fake data set. Fake data set means I have created a data set using some vectors and using some calculation and using some random value. So you can say that whenever you want to create your own data set, by this mechanism you can create your own arbitrary data set. Anyways, here we have three variables, y, x1 and x2. means x1 and x2 are features and y is the outcome. So here my intention is to find out the LM function. And what is the rule of writing the LM function? In the left hand side, we will write what we are going to predict. We are going to predict y. And in the right hand side, what we will write? We will write features. So here, since we have two features, x1 and x2, so therefore we are writing x1 plus x2. If we have three features, then we will write x1 plus x2 plus x3. Now, after applying LM function, then only we can apply summary function. So now after summary function, we encounter with the terms like residual error, residual standard error, this thing. So what is the formula of residual error? I have already written this one. So residual error will be calculated by this formula. Means here the coefficients are involved, and what is the meaning of this model? Meaning of this model means whatever output is provided by the LM function, it is stored in the model. And whenever you are going to compute the residual standard error at this point of time, you need to think the outcome of the LM function and the coefficients of your equation. Now, what is the meaning of dollar sign? See, dollar sign in R is used to fetch the value of the variable. Here, each and every column is considered as variable. See, by using R code, I want to fetch the column fixed acidity. So, column is treated as variable. So, I can write dollar fixed acidity. So, what is the meaning of dollar? Meaning of dollar means after this output model, which is holding the value of LM, now I am going to fetch the values under the coefficient column. So that's why I'm just writing dollar coefficient. So dollar is used to fetch variable in R, then -1. And why we are writing -1, I have written this one. In order to ignore the intercept, always we have to subtract -1. And what is the meaning of intercept? I think you know this thing. So whenever you are using straight line, if I write y equal to mx, means no intercept is there, means the line is passing through the origin. And whenever I'm writing y equal to mx plus b, this line may pass from here or here, means it has one intercept, say b, right? So this is the concept of intercept. So here try to understand, while calculating residual error, subtracting 1 in order to ignore the intercept is important. And then we have to find out the value of ACC. ACC means some standard error we are calculating, which is a sum of the value model and the residual values and then multiplied by 2. So these are just the formula. So why I have written this one, try to understand. Whenever we are clicking on summary function over here, as a output what we are just getting the residual value as this. But how could we understand that what do you mean by residual? So the entire calculation of finding residual error, the formula I have written here. So if you give any value, it will calculate the residual standard error. So for that purpose, I have created one fake data set here where you have these values and I have calculated the residual error. So please memorize what are the formula of standard residual error. And then again, whenever we are clicking on summary function, we are getting another concept of multiple R squared. So this multiple R squared are used for coefficient determination. And what is the formula of multiple R squared? Again, I have written the formula of finding multiple R squared. But here I have given one alternative approach. Means if you execute this line, then whatever value you will get, the same value can be calculated by this. So basically we have two approaches of calculating multiple R square. And then you have to find out the adjusted R square. So what is the meaning of adjusted R square? So R square error, residual standard error we have already considered, and here you have to just check the formula how we can calculate the adjusted R square error. Here we are using the same concept of subtracting 1 in order to ignore the intercept. And then we have the concept of F statistics. So here I have not written anything because next day I will explain all the concept theoretically and mathematically so that you could have more idea about this statistical significance. I think you can remember that I have explained about some hypothesis analysis. Hypothesis analysis means first I will consider that all coefficients are zero, and then I will consider that at least one coefficients are non-zero. So on the basis of this two hypothesis value, null hypothesis and alternative hypothesis, we can calculate something. So this F statistics are also used for hypothesis analysis. So anyways, what is our topic of discussion? Today our topic of discussion was why statistical analysis is important for us. So in order to explain that thing, I have explained one machine learning model, that is linear regression. And why I was using that machine learning model? So that I could predict something on the basis of some input. Now, while prediction, I have understood that, okay, training process is very much important. Means my machine learning model can only perform well if the training process is very good. If the training process is not good, then we cannot perform testing on that. We cannot use the predict function. Now, while performing training, how we could understand that training is good or bad? So at this point of time, we have considered one summary function. And this summary function will give us the amount of average error that has encountered at the time of training. Now here the problem is the summary function itself contains lots of statistical values. And this thing will be our topic, means understanding residual error is not so easy. Residual error is not just one value. Residual error means it's a combination of so many different kinds of error. Residual standard error, adjusted R square error, F statistics, p value, everything is involved. So we have to understand everything so that we could understand how much residual error is provided by our model, right? So this is the point why we need statistical analysis in R.